Hello, my name is Nazeer from the Faculty of Civil Engineering Technology. Welcome to all of you in Canada, and for those international viewers, welcome to you too. Nice to have you with us. What we have on the screen here is a binomial and its cube, and we want to take the derivative of this whole expression. When we look at this here, the problem with this is that we cannot just go and take the derivative of each one of the terms. We have to take the derivative of the outside first and then the derivative of the inside. And we have to remember to carry our notation. Let's go and look at this a little bit more in detail. This is our notation for y, dy dx, and of course we're going to do the derivative of the outside, and then we're going to multiply that by the derivative of the inside. The derivative of the outside will become, you're going to take the power and multiply the binomial and reduce that power by 1. And then we would go and do the derivative of the inside, which is 2 times 7 is 14x. We're going to reduce the power by 1 also. And this one will become just minus 4. So when we look at the derivative part of this, we have taken the 3 and multiplied the binomial and reduced the power by 1. And then we're going to go on the inside of it. 2 times 7 is 14x, reduce the power by 1, and this here, you reduce the power by 1, this becomes 1, so it'll be minus 4 right there. And this is the derivative part of it. It's called the chain rule. And of course we could leave this in this form, but it's not proper to do so. We have to multiply out this particular binomial here by the 3, and we could go also and expand this binomial squared, but I think it's okay to just leave it at that point. So when we look at this, 3 times 14 will give you 42x, and 3 times 4 will give you minus 12. So that's where we want to go with it, and we'll leave it in that form. Your instructor, your prof should tell you what form they would want to leave it in. But that's how simple the chain rule is. And this one is a little bit different. When I examine this, we certainly have a binomial to the 4th power, so I know that if I'm going to do the derivative of this, I'm going to have to use the chain rule. But also I do have a product. Okay, so I'm going to have to use the product formula. The product formula says if you have a product and you're going to do the derivative of it, you're going to take the first factor and multiply it by the derivative of the second factor. Right there. First factor, derivative of the second factor. Put a plus sign in between, take the second factor and multiply it by the derivative of the first factor. So that's the process that we're going to use, and as we go through that, we will be using the chain rule also in there. So let's go and look at this. dy dx, the y becomes that. We take the first factor and then we take the derivative of this particular. So the derivative of this would be 4 times the binomial reduce the power by 1, will become q, and then you go on the inside and take the derivative of that and multiply it out. Derivative of a constant will be 0, and we have 5x to the 4th right there. We're going to put the plus sign in between, and then we will take the second factor, place it there, and take the derivative of the first and multiply it. So when we look at this, this will be 3 times 2 is 6x squared, and that's where that is. Now, as far as the derivative part of this, it's completed. We have to use algebra to simplify this, put it in its prime form, and then we have a complete problem. When I look at this, I'm seeing that we have 2 times 4 is 8, times 5 is 40, and then x cubed and x to the 4th will give you x to the 7th. So we have 40x to the 7th. This binomial cube will stay as is, and then I will look at what we could do after that. So these three factors become 1 right there. We have this guy here just right there as usual. And then when we look at this, we will see that we have some commonalities between this. First of all, the binomial here and the binomial here have the same content. The powers is different, but we have commonality, which means we could take out a common factor. When we look at this guy here and this guy here, we also have a 2 I could see there, and a 2 for the coefficients, and the lowest power could come out of that also. So we have 2x squared that could be taken out, and then the lowest power of the binomial also could be taken out. So when we look at, we've taken out these common factors. If we were to divide this back into there, let's start off with this. Anything divided by itself will become 1, and this into 40x to the 7 will give you 20x to the 5th right there. Okay, and then again I'm going to divide this into there, and when you subtract 3 from 4 you'll get 1, so this is to the power of 1. So we have that done, and I'm going to divide this into the 6x squared. The x squared will cancel out and become 1, and we have 3 remaining. So that's what we have. We have taken out 2 common factors actually from this, and we have simplified it to this. When we look on the inside of this now, I could go and multiply this out. This will become 6 plus 3x to the 5th, and then when we have 3x to the 5th plus 20x to the 5th will give you 23x to the 5th plus 6, and that would be your second step. 23x to the 5th plus 6, and that would be your final answer. Okay, I hope that this helps you with your study of the chain rule, and if you like the video, please do hit the subscribe button and give me a thumbs up. Appreciate